What about the first one? First one.
It's
None. Neither one. Right? Why not? Good. The degree of the numerator is 2 more than the degree of the denominator, so no horizontal, no slant. Second one? Y equals 3. Third one? Y equals 0. Bottom has a higher degree. Fourth one, we would have to divide. I'm going to go really quick through that.
Okay.
12, is that 12x? So plus 12. So y equals 2x plus 12. Questions, comments, thoughts? Okay, today we're going to learn how to solve equations and inequalities. Emphasis on inequalities. We're going to spend a little bit of time on a few equations, but we're going to spend the bulk of today on inequalities. So what you couldn't do on that worksheet last night, hopefully we'll pick that up today. Okay, rational functions, rational equations, there are several different methods you can choose to solve them. You can multiply everything by the least common denominator. You can get a common denominator. You can do several things. Probably the most efficient way, maybe you could argue, and I would go, okay, sounds great, is to get a common denominator on both sides. This one needs an x minus 3. What does the second one need?
X minus 1.
And what about the one on the right?
You add them both to get multiple.
If you factored this, doesn't it already have those two pieces of the denominator? So it's good to go. So I get 2x squared minus 6x plus x minus 1 equals 2. Now, notice I didn't write the denominator, but if they are truly the same, then would I need a denominator anymore? No, so I'm going to ignore the denominator. It's not gone. I'm just going to ignore it just for a minute. That is factorable. What do y'all use? Korean? Is that right for this class? Just throw stuff in there and until it works. That's kind of what I do. Any questions so far? Good so far?
Good.
So I get x is 3 and negative 1/2. Is that the correct answer? Why not? Can't be 3, right? Why can't it be 3? Good, it's vertical asymptote. I can't plug 3 in. I can try, but it would give me an undefined value, not a number. So I have to be careful about those denominators. Other than that, that's how you solve those.
So if it's anything like that equals the denominator?
Anything that makes the denominator 0. That makes sense. Because it would cause an undefined point. Any questions about that one? Do we need to see this next one?
No, it's just.
Are we good with solving rational equations? Okay, so let's go to inequalities. Probably the one we need the most help on. You do have a note card that walks you through how to solve inequalities. I think. Does that sound right? If not, we'll do it. So, essentially, I know that this is a polynomial function with zeros 1 and 3. Everyone agree with that? And I want to know when it's less than 0. Well, when it crosses the x-axis, that's when it's going to change from greater than 0 to less than 0, or vice versa, right? It goes, when it crosses the x-axis, go from positive to negative or negative to positive. So the way that we do these by hand is to take a number line. I'll try again.
Use the line.
I'm still crooked. You'll be fine. So 1 and 3. Okay, any questions about that so far? Okay, so I want to know a number less than 1, does that make me have a positive value or a negative value? So I'm going to take a number less than 1, like 0, and plug it in. 0 minus 1 is negative 1. 0 minus 3 is negative 3, but what am I doing to that negative 3? So it's actually positive 9, so positive times a negative gives me a negative.
And then it's opposite.
Maybe.
Maybe.
Don't assume.
Potentially.
Don't assume. Assuming is a bad idea. Always. Plug in 2. 2 gives me a positive, which is positive. And then what about 4?
Negative. Negative.
Say that again. What was the question on this? Did someone ask a question? It doesn't matter. Either way. We're flexible. It is positive. So Drew's question earlier, do these always switch positive, negative? No, so be careful. Now, those of you who are quite advanced mathematics students, Mike could pick out that this has a multiplicity of 2. Remember, that causes it to just bounce off the x-axis instead of cross? That's why it didn't change.
I noticed it the whole way.
The question was, when is it less than 0? Now that I have the sign chart, that becomes a much easier answer. Because what kinds of numbers are less than 0? Negatives. Any questions about that one?
Would you ever use brackets?
Yes. When would you use brackets? If it's less than or equal to, then you want to bracket any values that are zeros, because then equal to 0 you would want to include. We'll talk about that more in a second. Okay, this one I don't want to do without 0 on one side. However, you can solve it before you get 0 on one side. So, side note. I'm going to solve, so step 1, did y'all find a note card? No? You might not have one. Step 1, solve the related equation, which I think I have the steps somewhere, maybe not. No.
Did you ever test graded for this?
Uh-huh.
Are they on that line?
No, but they will be today. I graded them this morning. So, step 1, solve the equation for x. What you're finding is zeros and undefined points. Try to find any zeros, any undefined points. You can solve before you get 0 on one side. Eventually, you will have to get 0 on one side. So I'm going to side note and solve. The reason I would want to solve this without getting 0 on one side is because I can solve it by taking square roots. Everyone know what I mean by that? If I got 0 on one side, I'd have to use the quadratic formula, which works okay. It does. And this one was just set up so nicely to solve by taking square roots. Now I'm going to go back and get 0 on one side. So step 2, get 0 on one side of the equation. Why is it important if I'm using a sign chart to have 0 on one side?
Because you have to find it is equal to 0 or negative.
Right. Positives and negatives mean nothing if I'm not looking at greater than or equal to 0. Because 1 is positive, but it's less than 2. It wouldn't help. Mm-hmm.
So you plug in a 4.
So my two numbers are 4 plus radical 2 and 4 minus radical 2. Okay, everyone agree with that? Notice I'm completely without a calculator, so I'm going to leave those like that. And a lot of people go, well, how do you choose numbers? Well, just choose wisely. What's something guaranteed to be less than 4 minus the square root of 2?
0.
0. Good. 0 is definitely less than 4 minus radical 2. And if you were unsure,
Negative a million.
sure, right? I mean, pick something less. Pick whatever you want.
Ah.
If I pick a number less than, so 0, something like that. 4 squared is 16. 16 minus 2 is a positive number. If you picked a million, you would get a positive number, wouldn't you? Negative a million. Positive a million would also give you a positive number. Does everyone agree with that? Here's the one tricky one. What's a number guaranteed to be in between 4 minus radical 2 and 4 plus radical 2?
4.
Oh, look at you go. So 4 minus radical 2 to 4 plus radical 2. I also want to point out, because you are such advanced mathematical students, the thought process of graphically. Now, I don't have a calculator, so I'm not going to just throw it in the calculator and look at the graph, but isn't this a quadratic function moved right 4 down 2? So you could also know that this was going to be plus minus plus because it was a quadratic opening up, so where it's going to fall against the x-axis would be plus minus plus. So you can think graphically. We're just going to combine both. Factor out an x. I'm going to go fast through these if that's okay with you. To do as many examples as possible. Is this coming back? I don't know. We need to do a rational example. I get a number less than negative 1? Negative 2 or something? If I plug that in, I would get a negative times a negative times a negative, which is negative. Now, notice I did not actually find a number. Would it have taken my brain longer to actually get a number value for that? Yeah, and I don't need a number. I just need to know if it's positive or negative. So use that to your advantage. Negative 1/2, negative, negative, positive, right? Which would be positive. 2 negatives multiply to give me a positive. Positive 1. Positive, negative, positive, which is negative. And positive, 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 which is positive. Notice there were no multiplicities greater than 1. So, Drew, you asked earlier again, can I assume switching positive to negative and vice versa? Well, if there are no multiplicities greater than 1, if there are no even multiplicities, then yes, you can make that assumption. But just be careful with assumptions. Okay, the bottom one, I don't know. I don't think so. Whoops. Oh, sorry. Good question.
Negative infinity to negative 1, 0 to 2.
We do want less than 0. Negative infinity. Come on, pen. To negative 1 bracket. Why brackets?
Equal to.
Good. And then 0 to 2. At 0, 2, and negative 1, doesn't this equation equal 0? So I want to include those in my answer. Solve the rational function equal to 0. When do rational functions equal 0? We should be pretty good at that at this point.
Numerator equals 0.
When the numerator equals 0, right? So I'm going to factor x times x squared minus 4. Factor that one more time. I get x plus 2, x minus 2. Does the bottom factor?
No.
On a rational function, I want all points that make the equation equal 0 or make the equation undefined. Does a graph change from positive to negative at an asymptote sometimes? Yes, so I want all of those on my sign chart. This one's a little strange because does that denominator ever equal 0?
No.
No, so this particular one I only get -2, 0, and 2. But if that denominator had equaled 0, I would put those points on my sign chart as well. So put all solutions and undefined points. Plug in values. Everyone agree that denominator is always positive?
Yeah.
So -3 would give me negative, negative, negative. 1 would give me negative, positive, negative. 1 would give me positive, positive, negative. And 3 would give me all positives. I want greater than or equal to 0. So -2 to 0. 2 to infinity. Okay, a little bit more complicated one. Has a denominator. We're going to do both of these. I know y'all don't want to, but you'll be okay. Start with this one. What makes the numerator equal 0? What makes the denominator equal 0? Okay, on my sign chart, I'm going to designate the difference between the undefined points and the zeros. Right, Devin? So I'm going to label the -3 and 3 as undefined. Why are they undefined and not zeros?
Sure, you don't put brackets.
They make the bottom equal to 0, and I need to know that because I don't want to include them in my or equal to 0 answer. They don't make this equal 0, they make it undefined. Does that make sense? So number less than -3, so -4. I get a positive on the top, negative on the bottom, so I get a negative. -2.5. -2.5, right? Y'all okay with this? -2.5 squared is less than 9, so I get a negative on the bottom and a negative on the top, which is positive. 0, I get a -4, I get a positive. Am I going too fast on where I'm getting the plus? Any questions on that? Okay, so I want greater than or equal to 0. I'm going to pick -3 to -2, and I'm going to bracket the 2, but I'm not going to bracket the -3. Does everyone understand why? Because that part is undefined. And then from 3 to infinity, and again, I'm not going to bracket the 3. Any questions about that one? Okay, let's look at the next one. You can tell I'm picking some nasty ones that you might have looked at before today and gone, I can't do that. Maybe. The solving's pretty easy on this one. What makes the top 0?
3.
And something I haven't mentioned, make sure that you pay attention to, 0 does have to be on one side for all of this to work, right? Everyone agree with that? So make sure you get 0 on one side. These all happen to have 0 on one side. If they don't, get a common denominator, move it over, and get 0 on one side. -2 makes the bottom 0. Would you agree?
Yes.
There's absolute values there, but it doesn't matter. The absolute value of 0 is still 0, right? Okay, pick a number less than -2. -7? Maybe? negative, what's the bottom always? So I actually get a negative, right? 0, I would get a negative as well. Why do I not change there? The absolute values kind of change things. So again, assuming is a bad idea. Assuming that we switch from positive to negative every time. 4, I would get a positive there. I want negatives. I do have to break it -2. Do you agree with that? Why? Why can't I just say negative infinity all the way to 3? There is no point at -2, so it's not a negative because there's nothing there. Does that make sense? Drew, stay with me. Not you, Drew. The other Drew. The one that's looking very sleepy. Okay, what 2 points would I put on my sign chart here?
Hold on. I just set 2x plus 4.
Good. Even though this looks nasty, isn't it already factored?
Negative 1/2 and 4/3.
-1/2 and 4/3. I like it. So where'd we get that? Set each piece equal to 0. Yes.
So it doesn't really matter. But
Not for the places where it equals 0, because since it's in factored form, if any piece equals 0, the whole thing would equal 0, because it's the multiplication.
Yeah, it's like
it only matters whenever you
Hey, that's right. So we're using the zero product property to solve things that you may have not ever even solved before, but it works the same as factoring.
Yep.
A number less than -1/2? -1. Uh-oh. I can't even plug -1 in.
What? Oh,
There's a square.
yeah. Oh, then you get
Okay, does it make sense that a square root equation would have a large interval with an undefined place?
Yes.
Yeah, because it starts somewhere and goes to the right, probably. Plug in 0, I would get a negative times a positive, which is? Negative. Plug in 7, sure. Okay, and you would get a positive times a positive, which is? Positive. I want less than or equal to 0, so we are going to be from -1/2 to 4/3. Neither of those were undefined points, were they?
No.
So I put both of those in as brackets. Maybe. Let me see what else we've got. Do we know how to solve absolute value equations? Does everyone agree with that? If you feel like you've got it, you can work on your homework. But stay where you're at for now. But let me finish working. Yes, ma'am. I can't. So when I plug in -1 into the square root, I get -1 under a square root. What's the square root of -1? It's non-real. Does that make sense? You can do either one. You could put no real, or you could show the I answers. I would take both. It'd probably be good practice for ACT purposes to go ahead and do the I's. For calculus, your answer would be no real answer. Do I need to stay, or you?
What's quadratic theory?
The what? Oh, the zero product property? Is that what you're...
Quadratic.
Oh, the quadratic formula? x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I don't know if that's... Did y'all learn that song? Except Pop goes the answer. Or something.
We just say negative b plus.
Okay.
X equals whatever you grab you said.
Probably the same thing.
Hey, we go to
Just a minute. I'm going to work them all. I'll go fast. Okay. Just because you don't need the top one doesn't mean someone doesn't.
Okay, yeah, but on Algebra 1, teach
Algebra 1 was a long time ago. Okay, any questions about how to solve absolute value equations? Good?
We good, homie.
Excuse you.
Okay, if you have a double absolute value, let me get into some technicalities and then tell you the quick way to solve it. Technically, this means 3x minus 2 could be positive or negative, and technically 2x plus 4 could be positive or negative. However, solving principle-wise, even though there's 4 things there, 2 of those sets of equations would be completely equivalent, wouldn't they?
Yeah.
So because of that, and because we're lazy math people, we'll just call one side plus or minus and go with it. Technically, there's a plus or minus on both sides, but does everyone know what I mean by 2 of those equations would give you the exact same answer? Because a negative equaling a negative would divide out to be a positive equaling a positive. And then a negative on the left and a positive on the right, and the positive on the right and a negative on the left is just going to divide out a -1, you get the same thing. Be careful, make sure you distribute that negative. So I get negative 2x minus 4 as one of my equations, and then my other equation as 3x minus 2 equals 2x plus 4. Solve both equations. And then the one on the right, x equals 6. Check your answers on absolute value equations. Did everyone hear me? Yeah. Check your answers on absolute value equations. Make sure they both work. Here's why. Everyone look with me really quick. You could solve this like any other absolute value equation and you would get an answer. Everyone know what I mean by that? You'd get a number answer. But you tell me, when does the absolute value of something equal a negative number?
Never.
It doesn't. So that's what I mean by check your answer.
So we're not including any imaginary numbers or anything when we're solving, right?
Right. On the quadratics, if you want to show an imaginary, it's good practice for ACT, but you don't have to. Okay, these are some more polynomials. Do we need to do any? Actually, I think we did both of those. What about a rational without having 0 on one side? Would we like to do one of those?
Hey, on this front page, you said no credit will be given on inequalities by chart.
On inequalities.
Yeah, none of these were inequalities, so I guess that makes direction.
On the inequalities, do a sign chart.
I just talking about the packet.
The first thing I would probably do is make it equal 0 on one side. It is not the only way to work it, but that's probably what I would do because that's what the others looked like, and those weren't too bad. So, seems like making it look like the others that weren't too bad seems like a good idea. Get a common denominator. So this one needs an x plus 2. The second one needs an x plus 3. And I do want you all to pay attention on this one little part. That negative sign messes people up a lot. So I want to talk about that. You have to distribute it to each piece. Very good. Sounds like you had a good Algebra 2 teacher.
Or a good brain.
Probably both. Yes. So I get x squared minus 4 on that top left. Minus, and I'm going to leave that as a negative, and I'm going to put parentheses. Don't forget to distribute the negative at some point. Some of you might be able to do that in your head, but be careful. X squared plus 3x minus 1, so plus 2x minus 3. All over. Leave the denominator factored, because you want to know when it equals 0. So multiplying it out, you would just end up having to go back and undo that. So simplify the top. X squared minus x squared cancels. This is negative and positive. So I get negative 2x minus 1 on the top. And now this is like one of the other problems that we did on the last slide. Negative 3, negative 2, and negative 1/2. Is that right? On this one, I'm not even going to label my undefined points. Why not?
Oh, because you don't need to.
I don't need to. You can if you want to. The negative 3 and the negative 2 are undefined. But I don't need to know on this one because it's just less than 0, not less than or equal to. Does that make sense? Plug in numbers, negative 4. I get a positive on top, negative, negative, which makes a positive. Okay, those of you, because I'm starting to have a hard time telling who's with me and who's not. Those of you who are still with me, does anyone need me to slow down? We okay on pace?
How many people are still with it?
There's quite a few.
How many people? Good.
Negative 2.5. I don't know if that's a safe place to be or not. I'm sorry. Couldn't help it. On the top, I get a positive. On the bottom, I get a negative, which gives me negative. Negative 1 is in between negative 2 and negative 1/2. If I plug in negative 1, I get a positive on top and a positive on... Right? And then if I plug in positive 1, I get a negative on top and a positive on the bottoms. I'm looking for less than 0, so it will be negative 3 to negative 2. Negative 1/2 to infinity. I didn't have to think about brackets versus parentheses because it was just less than 0, but if it had been less than or equal to, the negative 1/2 would have gotten a bracket, but the others would not. Oops. Okay, I'm going to do the same thing on this one. I'm going to subtract the 3 over. I do need a common denominator, so I'm going to make this x. If nothing's on the bottom, it's a 1, right? So I need an x minus 5 multiplied by that 1. So I get 2x minus 1 minus 3x plus 15. Why plus 15? Good. Distribute that negative. So I get negative x plus 14 on top. Yep. X minus 5 on the bottom. So 5 and 14 go on my number line. And what am I going to note by the 5? Undefined. We going okay pace, or do I need to slow down? Good. Plug in 4 or 0 or anything you want that's less than 5. I would get a negative. Plug in something between 5 and 14. I would get a positive on top and a positive on the bottom. Plug in something bigger than 14, like 15, I would get a negative on top and positive on the bottom. I'm looking for greater than or equal to 0, so 5 to 14, bracket the 14, parenthesis the 5.
You know how you side noted earlier? It's like x minus 4 squared. Do you always have to side note it?
No, just make sure at some point you go back to the original and get 0 on one side.
But why?
Don't try to use the inequality in
Should
the...
we have done like x minus 4 squared minus 2? Like, how would we have
Okay,
done
which... this one?
that? Yes.
So I side noted because it was easier to side note by... easier to solve by side noting.
Mm-hmm.
If I had solved from this form, I would have had to FOIL that out and use the quadratic formula, which would have been a little yuckier. I could do that, but I just made a decision to solve
You
before.
don't have to always do that.
No,
It can be like,
you can put 0 on one side every time and solve.
okay.
It just may not be the easiest way to solve. So I was showing you if you see an easier way to solve.
I got it.
Does that make sense?
Yeah.
I've got more. Do we need more?
No.
We don't need more examples. We okay? I've got like 6 more. If anyone need more of anything? Or do we want to work? Work?
Work.
Okay.
Work.